Hey everybody, this is Larry. This is day 19 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's farm. I'm not gonna lie, I am leaving for the airport in about 2 hours, so maybe today will be a little bit quick, a little bit sloppy. We'll see how it goes. And also, this will be my last video in New York for this year. So yeah, I mean, there'll be more videos. It just won't be from New York. I'm very excited, so we'll see how it goes. Yeah. Okay, today we have 769 max chunks to make sorted. Yeah, okay. You're given an integer array of length n, represent permutation. Okay, you split array into some number of chunks and individually sort each chunk. After concatenating them, the result should equal the entire array. Return the largest number of chunks we can make to sort the array. Okay. Yeah, I mean, I think when you represent a chunk, it basically means, oh, n is 10. That's kind of really small, actually. I was going to say something about, I mean, I was going to play around with some ideas, but saying that n is equal to 10 actually makes this relatively trivial, honestly. Yeah, I mean, I don't know what else to say after I've seen it. The idea here is, of course, brute force in a way, right? Like, how many possibilities are there? Well, there are 10 numbers. What does that mean? That means that using ASCII art, you know, you have A, B, C, D, or whatever. If you have 4 numbers, I just start with 4 numbers because I'm too lazy to write down all 10. That means that there are 3 spaces between them, right? And in every space, you could say, oh, do I split here or do I not split here? That means that for 10 digits, you have 2 to the 9 number of splits. And even if you times that by 10 for the work that you have to do, or even 10 squared, right? 10 squared times 2 to the 9 will be fast enough. So, or even 10 cubed, really. My point is that it's going to be fast enough with some sort of variation of this brute force. And yeah, and I think that should be good to go. Yeah. And the idea here is that, you know, you just yeah, and I think there are other ideas, but I think you can actually just keep the min and the max inside a chunk. And the reason is because this is a permutation, and therefore, if your chunk is not exactly represents the indexes, then it is not possible, right? Because of the pigeonhole. Meaning, for example, if your 2 is inside another chunk, then it's going to show up in someone else's min, or maybe put another way is that if you have a chunk of 2 digits or 2 numbers, it has to be exactly, like the min and the max has to be exact and has to contain 2 numbers, right? Or if it has 5 numbers, then the min has to be equal to the max minus 4, and there has to be 5 digits in numbers in between them because they're all unique. You know, so something like that. I don't know if I'm saying it right, but hopefully the idea gets across. So from that, I think it's actually enough to kind of keep track of the min and the max of a chunk. Yeah. Yeah, and then it just becomes yeah, figuring how to implement it. So yeah, let's do that. Right. I was actually gonna play around with something like maybe DP or something like that. I don't know. Based off those ideas, but like I said, saying that n is equal to 10, I mean, you know, let's just do it. Right, and maybe we have a function. I use Go a lot. Maybe that's a terrible name. It just so that I don't think I have to think about naming. But is it really that much worse than like recurse for recursion or something? I don't know. But yeah, so we have the current index. Maybe we have the min max count or something like that, right? And yeah, I think some of this is over more than necessary, but that's fine. It's still going to be what we said about the complexity, right? And the idea is just going to be take no take, but if index is equal to n, then we're basically done. I wouldn't say I want to say this is return 0, but I don't think that's necessarily true yet because we still have to validate min and max. So we'll just leave this here for now. So I know that this is not done yet, right? So yeah, hang on, right? Or maybe it can be. It depends on how we do the validation. But for now, we'll just add a mental note that we have to maybe at least think about it. But sometimes it is easy to forget. But okay. So yeah, so let's say, how do we want to start off? We want to start with 0, min and the max. How do we want to start off? I mean, I want to say min would be infinity, negative infinity, and count is 0, say, right? And then here we can do the classic tick, no tick, right? And actually, maybe this doesn't even make sense because we will never tick 1 before the 0th element. So maybe we start at the index 1, we set the first element to be array sub 0. Maybe that's a little bit more sensible, and we have 1 as a count, right? And then yeah, we just take no tick, right? So then the tick would be to end this chunk, or no tick would be to continue this chunk, right? What would take this chunk look like? Well, we go index plus 1. We have the min will be min of min and array sub index, not 1. And then max would be max array sub index, right? And then count plus 1, right? But is this a good chunk, right? So now we have to do some maths, maybe. I don't know. And the no tick is actually, oh no, and this chunk may be wrong actually. So because then now we start a new chunk, so count would be 1, and so actually I already messed up. I confused the two chunks, or the two statements, right? So this is to start a new chunk, but we have to make sure that we can end this chunk first, right? We have to validate it, or maybe we already validated with continue this chunk, so maybe that's fine. But yeah, so if we tick and we end this chunk, that means that we get a plus 1 on the chunks, right? So then that's good. And that means that this has to be checked, because that means that when we go to the last index, min and max are not trivial values. We have to, you know, to do end this chunk, possibly. Okay, so now we have to do the actual check, right, of can we end this chunk, right? Okay. Sorry, I don't know why I'm having some sniffles. But yeah, so basically we can end this chunk if we're at the current index, right? So we are at index with count as the last numbers that to count. So what does that mean? So okay, that means that we could, and the way that I sometimes think about this, instead of worry about off by ones and stuff, is just plug in real numbers and think about it, right? For example, we have index 5, and count is just start with 1, right? So count is at 1. What does that mean? That means that min should equal to so that means that for index is equal to 5, you already have 0, 1, 2, 3, 4, and then now yeah, we're indexed at 5, right? So these are the parameters, right? Or whatever, right? Yeah, actually no. Then if count is equal to 1, that means that everything is already settled and you have a new thing. So that means that min has to be equal to actually index, right? 1 or index. Max is equal to also 5 or index, right? Index, right? Okay, so what if count is equal to 2, right? If count is equal to 2, that means that we want 4 and the 5 in the last 2 digits. That means that min is equal to 4, or index minus 1, or index minus count plus 1. Right, and then max is equal to also still 5, which is index. So okay, so I mean I think, and this is also minus count plus 1, which of course count is being 1, they cancelled out. So I think now we have an idea of what min and max should be, right? So we can yeah, we can end this chunk only if that's the case. So if if min is equal to index minus count plus 1 and max is equal to index, then we can end this chunk. Otherwise, we have to continue this chunk, maybe hoping that in the future it would match, right? So yeah, and then of course we just kind of best is equal to say 0, and then we just take best is equal to max best of this thing, and also take no take, right? So this feels like a dynamic programming, but of course we're not memorizing. There's no point in memorizing. Every input should be unique. So yeah. Oh, and of course we have to return. And of course now here we have to do this check again. Yeah, and I think this should be good. So if this is good, we return 1 for, actually we return 0, because then now we end this chunk and we're done. Maybe. Actually, I mean, I think I was a little bit inconsistent about it. We have to figure out whether we want to. So yeah, you just have to count up the contributions, right? And the question is whether we do the contribution on starting a chunk or ending a chunk, right? So that's kind of the story. And I think it makes more sense to do it when we end a chunk, because then otherwise, you know, here we can just do negative infinity as a result, and here we have 1 to kind of end the chunk, and that's pretty much it, hopefully. And that's basically the idea, though. Yeah, unless I'm off by 1 still. Ooh, well, 0 and 1 is definitely not right. Dun dun dun. So we do no take. We're on the max, right? Yeah. Huh. I guess this is because of this thing. But yeah, okay. I just want to make sure. Let's do negative 20 just so that it doesn't have a weird, crappy message. But this should never happen, because at the worst. Oh, because we never. No, this should always end the chunk eventually, because this goes to all the way to index plus 1, to all the way to index to the end, and then the min max should match. Am I missing something? Index should be. If index is n, count would be n, so that means that the max number. Oh, this. Am I off by 1? I guess so, right? Because it doesn't make sense that 0, 1, 2, 3, 4, 5. Because max will never be equal to index, is what I mean. Because. Yeah. I think when I did the examples, I confused the numbers a little bit, because where index is equal to 5, the last number is not equal to 5, right? Or this may be the new number we're adding, but actually we're looking at the previous chunk and we're only asking if we're ending, and we're ending. That means that we only care about 1 digit, right? So yeah, so I think I messed that up. This should be index minus 1, and this should be this minus 1, which should be this. Okay. A little bit better, but still not great, clearly. Okay, that's just really wrong. Okay. Is it a little bit better? I don't even know anymore, but and this chunk, so we take a plus 1. Okay, that makes sense. But continue this chunk, and we just kind of add to the bounds. Okay, that also seems fair. All right, let's print it out. I don't know anymore. Maybe I'm just being a little bit silly, honestly. Okay, so we start at 1. We have the 4, right? 2, 3, and then we have 5, which is what we should want. 5, 0, 4. Oh, I forgot to change this one. I guess that's why, or hopefully that's why. That is part of the. That's why I didn't really like to write it this way, is because now we have duplication of logic. Of course, you can clean it up with like you know, with good chunk or something like that, or chunk good. Index mx count, return this thing, right? So then we don't have to yeah, because that's pretty bad, honestly. that we had to debug that because we had duplication of code, right? Okay. So yeah, so this looks okay. What is another example that we can do? I don't know. I mean, I feel like, yeah, should be okay. Let's give it a quick submit unless I made another silly mistake. And yeah, there you go. 1724-day streak. I wonder how I did last time. If I have to guess, I probably did bit mask enumeration. Oh no. Oh, huh. This is even way smarter than the way I did it. I mean, honestly, this was kind of the way that I was starting to think about it. But then I just kind of was like, n is 10. I don't have to think about it anymore. But the idea here is that, yeah, I mean, you could maybe watch that video as well. But the idea here is that, yeah, if it's just like you have all these segments, right? And then, like if you have a 4, you have a 4 here, you know that it has to be the earliest place that it could be is, well, where it is, but it has to go to all the way to the last cell. So you kind of make it so that, well, anything containing the 4 has to be this chunk, and then you kind of just run the prefix sum algorithm on that, which is, yeah, yeah, and that's basically the idea. You go from the min and the max, you write out the prefix sum for the segments, and then you just kind of, yeah, keep track of how many new chunks that you can do at any time. But yeah, okay. But honestly, like I was thinking along those lines. That's why I was like starting to talk, and I was like, oh, n is equal to 10. You don't really have to think about it too much, because, well, n is equal to 10. But yeah, it's worth trying to do both ways. I think this way, even though obviously for this particular problem it is not dynamic programming or memorization, you could kind of see where the structure is, and I think for that it's kind of good practice to kind of work these things out. Yeah, well, that's all I have for today. That's all I have for this one. This is all I have for New York this year. It's been a fun year. I'll still be around though, so it's not the end of year yet. But thanks for watching. Yeah. Oh, I didn't go over the complexity really. Everything is O of 1, right? So actually, this is just O of 2 to the n, or n minus 1 if you want to say that, and O of I guess maybe times n. No, I don't think so. It's not super clear. But okay, yeah. But that is all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.